Hi friends, this is a very interesting interview question, very popular at companies like Google, and this is specifically asked for data scientist roles. And this question is all about basic knowledge of probability and your ability to work out the mathematical details. Again, there are multiple versions of this question. We'll start with the simpler version, which is an easier problem, but we will also talk about the extension of this and how to solve the extension of this using code. Right? So let's go step by step. Okay, first and foremost, let me pose the problem. So you have a data set D1, which consists of N1 values like X1, X2, so on and so forth, Xn1. Now for this data set, you are not given these values. You are not given X1, X2, so on and so forth, Xn1. You are not given these. All you're given is the sample mean of this data set D1. The sample mean, we'll write it as X1 bar. You're also given the sample variance, the biased version of sample variance, right? Not the unbiased version. So you're given the biased version of sample 1. You're given the biased version of the sample variance, which is S1 square. And you're also told the number of points that are there in dataset D1. Right? So N1 here is the number of points. Right? So you're only given these three values. You're given the number of points in dataset D1, sample mean, biased sample variance. You're not given these values. Similarly, you're given another data set D2 where you're given N2 values, right? So again, just to make the mathematics easier, I'm just indexing these values differently. Here the indices go from 1 to N1. Here the indices go from N1 plus 1 to N1 plus N2. So D2 has N2 points, right? These are the number of values or points that were given, right? So D2 dataset has N2 points. It has a sample mean of X2 bar, the biased sample variance of S2 squared. Again, you're given only these three values and these three values. You're not given the actual numerical values of X1 up to Xn1 plus N2. Again, this indexing I've just used to make the mathematics simpler when we solve the problem. Okay, cool. I hope this is clear. So given this data, given these six values now, our objective is as follows. Imagine I create a new data set D by combining D1 and D2. Right? I just combine D1 and D2, create a new data set. The data set will have values from X1, so on and so forth, Xn1 plus N2. Right? That's the indices. Right? You'll have the N1 values that are there in D1, the N2 values that are there in D2 also. Now, given this data set now, let's assume, again, we know the number of values here, right? N1 plus N2. Let's just say this is equal to N. Right? So this is the number of values that will be there in this data set D because we are combining D1 and D2. Now let's say the mean of this data set D is X bar and the biased variance of data set D is S square. Now the challenge here is this. Challenge here is to compute X bar and S square, which is these two values, which is the mean and the variance of data set D given the means of D1 and D2, the variances of D1 and D2, and the number of points in D1 and D2. Right? Here, remember that Xi's are not given to you. Now, in a typical interview setup, you are given a whiteboard and you are asked this question and you are asked to work out how do you obtain X bar and S square mathematically step by step. Right? Again, this is a basic mathematics, basic probability question with some algebra and basic mathematical skills. And this question is often regarded as an easy question at top product-based companies like Google. There are variations of this question which will make it slightly trickier and of medium difficulty. But this question itself is considered like an easy question, primarily to test your mathematical aptitude skills and basic knowledge of probability. Again, I want you to tackle this problem before you check out the rest of the solution. As a hint, you can say, please be patient and work out the mathematics step by step. Don't say this can't be done. I've seen a lot of interviews who say, hey, this can't be done without even thinking through. So this can be done. Please be patient and work out. Give it sufficient time. I strongly recommend that you at least spend 15 minutes solving this question before you check out the rest of the solution. In a typical interview setup, you might get about 10 to 15 minutes to solve this problem and its variations. Okay, cool. Now let me go into the solution itself. Let me break it down for you. Whenever any of these mathematical questions are there, it's good to write down what we have and what we want. First, I'm writing down what we have. We have N1 and N2, simple. We have X1 bar. What is X1 bar mathematically? X1 bar is 1 by N1, the summation of all Xi's from 1 to N1. right? This is basically the definition of what is a mean. This is the definition of a sample mean, right? I've just written this. Similarly, this is the sample mean of all the points in set D2 because the indices start from n1 plus 1 to n1 plus 2. This is just to make the mathematics simple. So we have this, we have this. Again, remember that this n1 can be plugged in here, right? So if you do n1 multiplied by x1 bar, you can get sum of all the points that are there in dataset D1. Similarly, if you take n2 here, right? If you multiply both sides by n2, you can get sum of all the points that are there in D2. That's an important transformation that we will use in the mathematics. Similarly, what is S1 square? Because we said this is a biased estimate, we are dividing by n1 and not n1 minus 1, right? So it's 1 by n1, the summation of xi minus x1 bar squared, right? Because this is the variance of, this is the sample variance of dataset D1. Again, here also you can take this n1 to the other side, or in other words, you can multiply both sides by n1. Similarly, same. I mean, this is a standard formula for sample mean and sample variance. Just it's better to write the math so that you can work out the details. Next, let's write down what do we want. We want x bar. What is x bar? X bar is 1 by n1 plus n2, the summation of all the points xi from 1 to n1 plus n2. We already have n1, we already have n2. All we need is a summation of all the points that are there in both the data sets. Again, the moment you see this, it should strike to you that this is trivial, right? Because you can get sum of all the points in your data set D1 by just multiplying x1 bar with n1. You can get the sum of all the points. You can get the sum of all the points in D2 by n2, by multiplying n2 with x2 bar. So you just sum up this plus this, which is nothing but n1 x1 plus n1 x1 bar plus n2 x2 bar. You get this summation, right? So this is very easy to obtain, right? Again, I'll show that to you mathematically. So you have n1, n2, you just have to figure this out. Similarly here, what is s squared? n1 you have, n2 you have. Now you just have to figure out these, right? Again, we'll go step by step. Arriving at x bar is trivial. Arriving at s bar is slightly harder than arriving at the mean, but it's also not very hard if you work out the math carefully. Let's go step by step. Okay. What is x bar? This is the formula for x bar. It is a summation of all the points in both D1 and D2 divided by n1 plus n2. Simple. Now this whole summation, I can break it up into two parts. This summation is a summation of all the points. Look at this. You have x1, x2, so on, so forth, xn. Then you have xn plus 1, so on, so forth, up to xn plus 1, xn1 plus n2. So the summation of all these points is the summation of these points plus the summation of these points. That's what I've written here. It's simple, right? Simple. I'm just breaking this summation into two summations. From I equals to 1 to n1, then from I equals to n1 plus 1 up to n1 plus n2. Now this I already know. Look at this. This I already know what this value is. This value is nothing but n1 x1 bar. It's this summation. Similarly, this summation is n2 x2 bar. Just plug in those values. So this becomes n1 x1 bar. This becomes n2 x2 bar. That's it. You got it. So you have these values because you have n1 and x1 bar. You have n2 and x2 bar. You have this. You have n1 and you have n2. So you can compute you can compute x bar. This is the mean of the data set D. This is literally very easy. I would say trivial to compute. Like this is like a high school 8th, 9th class mathematics problem, right? Actually, this whole problem is simple, to be honest with you. Okay, cool. Now let's go and tackle the slightly harder one, which is this is your variance of D, the sample variance of D, which is 1 by n1 plus n2. You have n1 plus n2. This is already available. It is a summation across all points xi minus x bar whole squared. You already have x bar, remember. You just computed x bar now, right? Using this formulation, you computed x bar, which means you can plug in that value here. So you have x bar, right? Now, again, this whole piece is trivial. You have it. Now the challenge lies in this piece. So let's try to tackle this piece first, right? So I've just written this whole expression again here. Now let's try to expand. This is like a minus b whole squared, right? So what is this? xi squared plus x bar squared minus, because there is a minus here, 2 into x bar xi, right? This is the summation. Again, remember that this whole expression is within the summation. Let's call this equation 1. Again, we have to solve this using what we have. Remember, to solve this, what do we have? We have these 4 equations. We have this equation, this equation. We also have x bar now. Using these 5, we have to somehow solve this expression, or solve this, you have to simplify this expression basically, right? Let's see how to do that. It's actually fairly simple. Now remember that n1 into s1 squared, remember, look at this expression. Okay, this expression, where did we get it from? Look at this, I explained this a while ago, right? n1 into s1 squared is just this expression, right? It is this expression. I've just written the same thing here, right? So n1 into s1 square is the summation of xi minus x1 bar squared. Now let's expand this, right? This a minus b whole squared, let's expand it. You get xi square plus x1 square or x1 bar squared minus, because there is a minus here, minus 2 into xi x1 bar. Now let's simplify this, right? So this is a summation of a summation, so we can break it up, right? So I can say summation of this, right? Summation of this, which is what I've written here, plus summation of this. Again, remember, this is a constant. x1 bar squared is a constant, right? Because it is the mean of all the points in D1. It is already, look at this, x1 bar is already given to us. So you just square it, it's a constant. Now, if you keep summing up I equals to 1 to n1, if you keep summing up a constant n1 times, what do you get? You get n1 times the constant. So this expression results in this, right? What about this? Here also x1 bar is a constant, 2 is a constant. So let's remove both of them outside the summation, right? So minus 2 into x1 bar. What should be there in the summation? Only this piece will be there in the summation. Now what is this piece? Now this is basically sum of all the points that are there in data set D1. Right? And what is that? That is nothing but n1 into x1 bar, right? Because we are already given mean. Again, what are we trying to do here? We're trying to get everything in terms of things like x1 bar, x2 bar, s1 squared, s2 squared, n1, n2. Because we know these, we have these values given. So we're trying to get everything into that form, right? Now look at this, okay? So this, I can't simplify it any further because I don't have xi values. So I'll keep it as is. Now this is n1 x1 bar squared. This is minus 2 x1 squared. Look at this. This is x1 bar. This is x1 bar. So this becomes x1 bar squared. There is n1. So this is plus n1 x1 bar squared minus 2 times n1 x1 bar squared. So if you just simplify it, you'll get this expression. So what do we have now? Look at this. What do we have? We have n1 into s1 squared equals to this summation minus this. Again, remember, if you notice this, I have n1, I have s1 square, I have n1 here, I have x1 bar squared also. So if I take this to the other side, means if I write it like this, n1 into x1 bar squared, right? If I just remove this and take it to the other side, I can get the sum of the squares of sum of all these values. Look at this. What is this? This is the square of sum of all the values that are there in data set D1. I can get it in terms of values that I already have. Very simple, right? If you think about it. So if I try to simplify it, this is the sum of all the values that are there in D1. The square. This is the sum of squares of all the values that are there in D1. I can write it using these, and I know n1, I know s1 square, I know n1, I know x1 bar squared. I know all these. Similarly, if I do the same math, just like the math that I have done here on dataset D1, if I do it for dataset D2, this is sum of squares of all the data points that are there in D2. It will be equal to the number of values in D2, s2 squared, n2, x2 bar squared. Same, right? Similarly, same, just like the way I got this, I can also get this. And this is equation 2, right? So we will use this. This is very, very important. Now remember, last time, where did we get stuck? So this is where we got stuck when we were trying to compute. Look at this. When we were trying to compute s square, this is where we stopped. Because in here, I didn't know how to tackle xi squares. I have this summation and I have these xi squares. I didn't know how to tackle this. Now I have a weapon in my hand to tackle it. Because the summation of the squares, I have it as an expression using terms that I already have. The summation of squares, I already have a way to tackle it. I have a way to compute that value using all the known values that are given to me, right? So let's go again. Okay, so let's again write it down. Again, typically you have s square, and here you have n1 plus n2. So I've just ignored this and I've moved this n1 plus n2 to the other side. Now I know n1, I know n2. What is s square? So I don't have this expression. Summation over all the points. Again, this expression is exactly same as this. It is the same expression as this. right? Remember, if you take n1 plus n2 to the other side, what you are left with is just this expression, right? The same expression I've just expanded and written it here. Simple logic, nothing fancy. I mean, simple algebra. This is like high school algebra. If you're careful with high school algebra, you'll get this, right? Okay, cool. Okay, so now let's break it down. Okay, this is summation of sum of a bunch of expressions. So I can break the summation, right? So I have summation over xi squared. So this is first expression corresponding to this. Remember that x bar squared, I already know x bar. I computed it a while ago, right? Since I know x bar, which is basically the mean of all the points that are there in the data set D, right? This is a constant. If I summate over a constant, what do I get? Same logic that we applied earlier, right? n1 plus n2 into x bar squared. So from this, I get this expression. From this, what do you get? What are constants here? 2 is a constant, minus 1 is a constant, x bar is a constant. So let's remove them outside the summation and put this here. Now, what is this? This is straightforward, right? What is this? This is nothing but, look at this. What is this? If you think about it logically, this is nothing but, this is basically sum of all the points that are there in in the data set D. What are the sum of all the points that are there in data set D? It is nothing but n1 plus n2 into x bar. That's it. Very simple, right? Now let's try to simplify it. Let's try to simplify it step by step. Okay. So first expression, I have this. This expression, we know how to express it. We have seen this, right? Look at this. So this expression is this. This expression is this, right? So I can just directly write that. So this whole summation of squares of all the points is summation is equal to this plus this. I have this now, right? So this expression boils down to this plus this. Now this is basically a constant, so we'll just place it here without changing it. Now what about this? Look at this. What is this? Minus 2x bar n1 plus n2 into x bar. Again, the same expression that I've written here, So this whole n1 plus n2 s square can be written as the slightly lengthy expression, but we'll simplify it quickly, right? So, okay, this is what we have now. I've just copy pasted whatever I have here. I've just copy pasted it here, okay, without any changes. Now let's see. Okay, so you have n1 s1 square. Let's just write it as this. Then you have n2 s2 square. Let's write it as this. Resolved. So this is resolved. This is resolved. Then you have n1 x1 bar squared. So let's just write that as this. Simple. Then you have n2 x2 bar. Just write it as this. Okay. Very simple, right? Now what else do you have? Remember, you have n1 into x bar squared. Here you have 2 into, you have an x bar here, you have an x bar here. So this becomes x bar squared. You can just ignore this. So you have plus n1 x bar squared minus, look at this, minus 2x bar squared n1. So if you simplify this expression, if you simplify this minus this, what you'll get is this, right? Simple logic, because there is minus here, right? So if you think about it, x bar squared is common. n1 plus n2, n1 plus n2. Here there is plus 1, here there is minus 2. So you'll be left with minus 1 into this whole thing. Now this is simple to compute. Look at this. What is this whole expression now? What this whole expression is n1 plus n2 into s square, right? So you have n1 here, you have n2, you have n1, you have s1 square, you have n2, you have s2 square, you have n1, you have x1 bar squared, you have n2, you have x2 bar squared, you have x bar, you have n1 and n2. So you have everything. The only unknown here is s squared. So you can say s squared equals to, you can take this whole expression to the other side, n1 plus n2. So you can compute s square, right? Very simple. Again, the objective here is to see how you work out these mathematical details carefully step by step, right? Now, if you think about it, this problem is a simple high school level aptitude problem about mean and variance. Again, mean and variance themselves are concepts in probability, but if you think about the core of it, this is basic. Summations are a concept that I think we learn in our high school, maybe 9th, 10th, 11th, 12th grade, right? So this is simply an aptitude problem around mean and variance concepts that we learn in probability. Now, as a simple extension to this, in some interviews, like even at Google, people ask you to write code for this, but not when you have dataset D1 and D2. Let's say this whole setup, right? What are we given? We're given N1, we are given X1 bar, you're given S1 squared, and you're given N2, X2 bar, and S2 squared, right? You're given these properties of two data sets. Now the question to make it slightly more interesting, a good extension to this is, what if you have k data sets like this instead of 2? So instead of D1 and D2, what you have is D1, D2, so on and so forth, dk. And for each of them, you're given the number of points. Like for example, for any di, you're given what are the number of points in the data set di. You're told what is xi bar, right? You're also given si squared. These three values are given for each of these data sets d1 to dk. Now the question here is, now can you write code to combine all these data sets? So let's assume there is a data set D, which is a combination of all of these data sets, D1 concatenated D2, so on and so forth. So this is a combination of D1 to dk. Now for D, can you compute what is x bar and s square? That is the question. Remember, there are k data sets, not 2 data sets. That's a nice extension, and very often when this extension is asked, again, it is typically asked when you answer the basic question quickly. If you answer the question when you have D1 and D2, and if you're able to work out the math and you show that you can make it work, a simple, nice extension to this is, hey, what happens if there are k data sets and can you implement it in code? The logic is actually very simple. Look at it. So you have D1. So imagine you write a function f that can combine D1 and D2, right? Or if you give me some properties of D1 and D2, like n1, x1 bar and s1 square. Similarly, the number of points, the mean and variance of D2. If you give me all this, I can combine them. Let's say I write a function to combine them. Now my objective is, how do you do it when you have k data sets like this? Very simple. Just divide and conquer, right? Simple divide and conquer approaches. This is something that you learn when you merge data sets, right? So similarly, look at this. You take D1 and D2, you pass them through this function, right? Let's call the output data set as D12, right? For D12 now, you have the mean, you have the standard deviation and the number of points. Similarly, merge or combine D3, D4. If you combine D3, D4, let's assume the data set you get is D34, right? For D34 now, you get the number of points, the mean and the variance, right? So keep combining 2 like this, right? So let's assume you have k, suppose if you have k data sets here, you will get roughly k by 2 data sets here. Roughly, of course, the seal of it, if you want to do a thorough mathematical analysis based on whether k is odd or even, right? So roughly you'll get k by 2 here. Now these again you can keep merging, right? You can merge these two now. Similarly, you can merge 2 more, you can merge 2 more. This whole, you can keep merging till the time you get D1k, which is the data set, which is a combination of all the data sets D1 to dk. Let me show you one more step here. After you get D12's properties or numerical values and D34's mean, standard deviation or mean, variance and number of points, you can combine D12 and D34 again by calling this function by passing D12 and D34. Now you get D14. A D14 is the data set which you get by combining from D1 to D4 the properties of this whole eventual data set. You keep merging this. This looks like a tree-like structure, right? This looks like a binary tree. This looks like a tree-like structure if you think about it from a computer science perspective. And this is what we do when we merge. Like if you know merge sort, this is what happens, right? Logically speaking, right? So this is a very interesting, simple divide and conquer, very simple, elegant approach that you can apply and translate it into code, right? So this whole problem itself, an interviewer can spend whole 30 minutes. They can start with first D1 and D2. If you solve this in about 10 minutes, they can say, hey, let's work out an extension to this where you have a problem from D1 to dk. Tell me how you'll solve it and let's write the code for it. This whole thing is a very good, neat gradation of the problem, right? You start with a simpler problem, you give a slightly more interesting problem, and you're also asking the candidate to code. So what is this question testing? Why is the interviewer asking this question? They're testing 3-4 things here. The first thing is, do you have the basic mathematical skills? Can you manipulate maths? Can you manipulate simple algebraic expressions, very simple stuff? And can you work out the details? This is all about, are you detail oriented? Can you work out the detailed mathematics? Again, especially at top product based companies like Google, they don't want you to just hand wave a solution. They don't want you to remember a solution. They want you to be able to work out the details. Because if you read a research paper or if you're working out some mathematics, if you're working out anything in data science, they want you to be rigorous with the nitty-gritty details of the mathematics. The last step, which is the extension, is to say, hey, can you code what you're telling me? Can you apply standard techniques in coding? Like like merging two of these data sets, and then keep doing it till the time you arrive at the final data set? Can you do this gracefully using techniques that are very common in computer science, very common in data science, right? So this is testing the very nice gradation problem, because we are starting with something easy, going to something that is medium, of course, with code. That's the best part about it, right? I hope you enjoyed this problem.